Hi, so welcome to this first lesson of our study of limits in calculus. So we're gonna go through the definition of limit and what it means, okay, the graphical point of view, and we'll take some other examples or some examples to solve in our next lessons. Okay. So limit of a function. Suppose the function f, okay, so I have a function f is defined for all x near a, right? What it means is this x is the input that you put in the function. So the function is defined for all the inputs you have near a particular point a, except possibly at a. So it can be that the function is not defined at exactly x equals a, or maybe when you put a inside the function, or it can be the function is defined. That's okay. If f of x is arbitrarily close, right, it's arbitrarily close to L. So what it means is as close to L as we like for all x sufficiently close but not equal to a, you write this. So what it means is this. You have your function f, okay, and let's say this is a. So if you look at values that are really close to a from this side and that side, okay, both left and right side of the values that are close to a, and you plug them in a given function, let's say f of x, right, and you get these from the left side of a, all the values that you have, when you plug them in the function is approximately equal to some particular value L. From the right side of a, if you plug them in, the same thing happens, okay. Then we say that L is the limit of the function as s get closer and closer to a. So in this particular lesson, what it's trying to say is that the graphical point of view is I'm gonna use that to explain to you more. What we are trying to say here is that suppose I have this graph of a function, okay, and there's this point a that I have here, and I have values that are close to a from both the right side and left side. Okay, so let me look at the left side of a. As I'm getting closer and closer and closer to a from the left side, okay, you realize the function value are these values, okay. They get to this point. I mean, if I'm far away from a on the left side, this is the value. The more I get closer and closer and closer, there will be a point that it will be almost getting to this value here, which is the L, okay. This is the L. So as I'm getting closer to a, the function value is getting closer and closer to this point. I mean, from that side, from the left side. If I look at the values on the right side, as I'm getting very closer and closer to a from the right side, the function value is also getting closer and closer to this point. So at this moment, what we say is that the limit as x approaches a of this function is equal to L. Now, one key thing you need to take from this lesson is that the limit is always a y value. Okay, the limit's value is always a y value, and this a is always an x value, or yeah, it's from the x. Okay, so as you get closer and closer to the x value from both sides of that particular value, the y value also get closer and closer to a particular value. Okay, so in this case, if I'm getting closer to a from the left side, the y value is getting closer to this point. Okay, let me use a different color, this particular point. If I'm getting closer to a from the left side, from the right side, the y value is getting closer to that. Okay, and I use that to explain. In the next lesson, we'll take problems where we have a graph and then we have to find our limits using the graph. Okay, so stay tuned and follow my lessons on limit. Thank you, and see you in our next lesson.